Cool. Okay, hi everyone. Thanks for coming out. My name is Suraj Rampure. I just finished my 5 years at Berkeley. So I was an undergrad for 4 years, and I did the 50 years master's program in computer science. And I'll be at UCSD this fall teaching in data science. Email there, but everything we're going to talk about today is Berkeley related. So what we're going to talk about today is a new pre-foundations course that we taught this past spring. It's called Introduction to Computational Thinking with Data, and I'm going to tell you all about it. But first, let's start with a little bit of, high level. What is this course? Like, what's the point? And some history as well. So, Data 8 in spring 2021. I'm assuming most people here are familiar with Data 8. In spring 2021, had almost 1,400 students, so it was massive. And though it is an introductory course in that it introduces both computation and inference without any prior knowledge, without any assumptions of prior knowledge, rather, 58% of the class did actually have prior programming experience, and 40% of the class had both prior programming and statistics experience. And so, that's fine. And Data 8 has no prerequisites, and it welcomes everyone, and anyone who wants to be a data science major or minor, regardless of what they've taken before, has to go through Data 8, because Data 8 approaches things in a way that is quite unique to it. But something that we noticed is that some students without prior programming experience are a little intimidated from taking Data 8 because it's just massive, and half the people in the course do have prior programming experience, and so there tend to be feelings of imposter syndrome and not belonging. So an idea that we had was to create a new small-scale pre-Data 8 course for students who are interested in data science but not confident in their abilities to succeed in Data 8. And so the idea is that students would take this course first and then later on take Data 8. And hopefully we do something in this course to make students feel compelled to take Data 8 and also feel that they'll succeed in Data 8. And so that's a good idea. But here are some student testimonies showing that there was room for this course in the Berkeley data science ecosystem. And so these are student responses on the application that we put out for students to enroll in the spring semester offering of the course. I'll just read one of them. For example, studying primarily humanities, I wanted to gain experience in another fairly unrelated sector like coding to help with potential careers, but was apprehensive about taking a large course, that's the key there, a large course like Data 8. Since I have no experience, I was worried I would fail Data 8, thus this is much more doable and supportive. So it seems like, at least from our first few offerings of the course, there is a demand for something like this, a small-scale tangential course at Berkeley. And so that's what we did. And so I'll be talking to you about the spring 21 offering of the course, but that wasn't actually the very first offering of the course that we're calling Introduction to Data. Rather, that started in summer 2017. It was offered as Data 8R, and it was taught by Henry Milner, who was one of the founding GSIs for Data 8, I believe. Then 3 years went by in the course, and in summer 2020, it was taught as Data 6 by Ian Castro, who will also be teaching it again this summer. The offering we're going to focus on is the one from this past spring called Data 94, and that was taught by me. And that will serve as the basis of the course moving forward, and it's what we will discuss today. It differs slightly from Data 6 and Data 8R in its approach. High-level goals are quite similar. 94 is a temporary course code at Berkeley, and the course website is linked there. Also, the slides are linked. I put a tiny URL before, but I can also put it again in the chat for those who just joined. That should be a link to the slide as well if you want to follow along, and the course website there too. Thank you, Ksenia. Okay, so we're going to talk about this Data 94 course, even though the title of this presentation is Data 6. Okay, so what are the goals of this course? One, it's to entice students to study data science further, right? This is not a replacement for Data 8. Rather, we want to encourage students to take this course. Hopefully we get them excited about data science, and then they go take data 8 and do whatever else. And as a result, we also wanted to prepare and build confidence in students for when they pursue data science coursework, right? So it's not just about exciting them, but it's also about getting them ready for taking data 8. But like many introductory courses, there will be some population of students in the course that take the class and then don't take data else we intended on them taking afterwards. And so another goal that we had was to give them something that they could use without needing to take any other courses. And I'll talk more about the kind of elements that we built into the course that helped meet this goal. But we wanted students to leave with being able to do something that didn't require them taking data 8. So the course is also not just a subset of data 8. It has some elements that aren't covered elsewhere in the curriculum. Okay, so those are the goals. Ryan Harvey in the chat, are you going to talk about why CS10 doesn't meet that need? Great question. So CS10 also serves to introduce computational thinking for those who are not aware. The difference between CS10 and data 6 is that data 6 is very data science focused, whereas I believe in CS10, it's more about computation as a whole, and I believe data science is mentioned at some point in CS10. Almost everything we do in data 6 is, with an eye towards data science. So that's kind of what differentiates them. But one is not really a replacement for the other. They both are complementary, I would say. Okay, so let's talk about the content in data 6. But to do that, we should start by talking about the content in data 8. Now, you've likely seen something like this before. Data 8 is kind of broken up into 3 big modules: computation, inference, and prediction. And a pioneering part about data 8 is that tables are introduced almost right in the second week. It's either in the second or third lecture of the course. Students are taught about tables. And this kind of makes sense, right? Because it's a data science course. Most of the data that we deal with, at least in the curriculum here at Berkeley, is tabular in nature. And it's kind of hard to deal with tabular data if you don't know what a table is. And so tables are introduced right away. Also, programming constructs are only introduced as they are made necessary rather than all at the start. And so, for example, the idea of a function is only brought up when talking about how to apply some procedure to every element of a column, rather than at the start as part of some okay, here's all the programming that you're going to need. Also, because data 8 isn't an introductory programming course, rather it's an introductory data science course, and we just heard how data science to us is computation and inferential thinking, there aren't things that introductory programming courses like while loops or dictionaries or recursion. Rather, we have a full-on treatment of inference. So tables are introduced at the start, programming is only brought up as necessary, and some more common or classical elements of introductory programming courses aren't in data 8. So now let me show you the data 6 syllabus. So you can see it has some overlap with the data 8 syllabus. It has a decent amount of overlap, but there are elements in data 8 that aren't in data 6 and vice versa. So what I want to do is first give you 30 seconds or so to take a look at the syllabus that's here. And then what I'm going to do is identify 3 key differences between the data 6 syllabus and the data and why we did them and how we sort of implemented things. So I'll let you look at this maybe 10 or 15 seconds. Okay, so what are the key differences between this syllabus and the data 8 syllabus? Well, one is the placement of tables, right? Whereas in data 8, you see tables right away. In this course, you don't see tables until week 7. Another big difference is that there are additional programming constructs that you don't see in data 8 that you do see here. You see while loops, for example, dictionaries. There are a few more that we'll talk about. And on a slightly more minor note, the placement and coverage of visualization is slightly different in this course compared to data 8. So we'll start by talking about the big one, the placement of tables. In data 6, we only talk about tables after we've talked about fundamental programming constructs. Why do we do this? Well, we did this in students would get table manipulation a little more easily if they, already went through the basics of learning how to program, rather than learning to program and work with tables at the same time. Now, it turns out that, and I'll show you a graphic from the end of semester survey. Students did find table manipulation to be easier than, say, things like while loops and for loops. Of course, we have no idea how this translates to how they'll find things in data 8, but that's information that we have for now. But this raises an issue, right? It makes it harder to motivate data science if you can't work with tabular data sets, which are kind of our bread and butter for now, because we're not seeing tables until later on in the semester. And so our solution was to use interactivity and visualization. And so what I want to do is switch to a Jupyter notebook and show of what I mean by that. To do this, I'm going to have to stop screen sharing, stop screen sharing, change the tab I'm sharing to, then I'll have to do this again. Okay, can everyone see my notebook? It seems like it. Okay. There's a comment in the chat, the syllabus. If you go to the course website, data94.org, you'll see everything there. Okay, so I have this notebook. I want to show you 3 examples of, cases where students only had to implement code that was relatively short and didn't have much to do with, or didn't have anything to do with, tabular data sets, but the end result was still fun and interesting for them to play with. Okay, so we'll start. The first example had students implement this function, BMI from INLB. Note that anytime you see a hashtag solution, that just means that's a line that students had to fill in on their own. So they were just shown this. They were kind of, this was in the first homework, so they were scaffolded to, write this. But anyway, students had to implement this function, which takes in someone's height in inches and weight in pounds and returns their body mass index. That's all they had to do. And then they were told to say, hey, okay, just run this cell. Don't worry about what's in it, but play with the visualization that comes out afterwards. And so you see here, we loaded in a data set of real people's heights and weights, and we applied their function to this data set so that you could see everyone's BMI as well. And then we asked them questions like, as people's height increase, do their BMIs tend to increase or decrease? And they can answer that question by looking at this plot. This was made using Plotly, which makes it interactive. So you can zoom into a subregion of the graph. You can highlight, or you can hover over a point, and it'll tell you the exact X and Y coordinates and whatever value you want to show as well. So BMI in this case. We use Plotly quite a bit in this class, and I'll talk more about that later. But yeah, in the first homework, all students had to do was say, okay, I take someone's height in inches, weight in pounds, and then they get to play with this cool visualization. The other 2 examples I'm going to show you were from the last homework before we moved to table manipulation. So this was the 4th homework in the course. We're about a month and a half into the course. Here we were talking about dictionaries. So what students had to do was define this dictionary. I told them what the 5 keys had to be. They had to be these words: happy, annoyed, tired, love, and food. And I said the values could be any emojis you wanted. And so there's a website online that will give you sort of standardized emojis, and students could pick whichever ones they wanted and define this dictionary called fave emojis. What they then had to do was define this function called emojify that would take in some string and apply, it would replace any instances of these 5 words, happy, annoyed, tired, love, and food, with the corresponding emoji. And again, anytime you see begin and end solution, it just means students had to come up with that on their own. So students saw the code in this format, and they had to eventually fill in something like this. So again, they don't have to do a ton here, right? Define a dictionary, write a for loop, only takes a couple lines. But after that, they got to play with this cool live text box, which we created using IPy widgets. And what it does is it, on the fly, implements their sorry, not implements, but uses their implementation of Emojify. So for example, if I say, love you, annoyed me with food, all the emojis are subbed in live. And so students got to play with this. And again, they got to pick the emojis that they wanted. So people had fun with this. And again, no tables involved at all. But it was, still kind of in the context of data science. How we kind of motivated this was by talking about the emoji, sorry, not the emoji keyboards, but the predictive emoji feature on iOS, where, if you're writing a word or a text message to someone and you write some word that they have an emoji for, on the iOS keyboard at least, it'll show you that emoji as one of the predictive options. We kind of motivated it using that. So we have this. The last example was also in homework 4, which is the same one as this text box one. This was when we were introducing NumPy arrays. So we spent some time talking about lists on their own. We then transitioned to NumPy arrays. And in this example, we had students implement 3 filters that work on images. So one was a grayscale filter where they take in the R, G, and B values for a single pixel and return the grayscale version of that, which is just averaging the R, G, and Bs. So they had to do that. Again, all they had to do here was fill in the 3 dots here. So they just have to recognize that it's np.mean, and they were given formulas for this as well. The next filter they had to implement was an X-ray filter, which is kind of just converting it to grayscale and then doing 255 minus that. And then there's a sepia filter, which uses just this transformation that I found online. And really, the NumPy method we wanted them to learn here was np.dot and np.clip to clip values to be between 0 and 255. So we had them just get their hands dirty with no tables involved, and the code that they had to write was relatively short. But after they did that, they had these 3 filters: grayscale, X-ray, and sepia. And after that, they got to play with this other widget, which we created using IPy widgets. And I'll show you it here. When you run this first cell, it gives you this file uploader box thing. So I'll click it, and I'll pick an image, a picture of our Campanile. Then you can pick between the 3 filters that they just implemented. So I'll just pick X-ray for now. And then when you run the next cell, you'll see the original image, and it's not the most efficient implementation, but they get to see their image converted to X-ray. And so if you change X-ray to sepia, the same kind of thing happens. The students got to see the image that they uploaded, followed by it converted to sepia eventually. Cool. Okay, so in the latter 2 examples, students got to bring in their own emojis or pictures, and it had nothing to do with tabular manipulation, but students were still excited about it. And that was one of the big goals of the course, which is why we thought this would be a worthwhile addition. And in the end of semester survey that we gave to students, roughly half the class said that this homework, the one that they dealt with emojis and images, was their favorite homework, even though there were no tables involved in it. So we just thought that was interesting, even though this is a data science flavored course. Okay, I'll switch back to the slides now. Okay, so those were the 3 examples we just looked at. So that was the first big difference between data 8 and data 6. It's the placement of tables. The issue was that it's hard to motivate data science. The solution is, you give them engaging examples, and they're not going to be bored in the class. Okay, now I want to talk about the additional programming constructs that we added to data 6 that are not in data 8. And the first of those is while loops. We covered these after if statements and before for loops, kind of as is done in the main CS course, or the introductory CS course for majors at Berkeley, CS61A. And we also used it as an opportunity to teach tracing. So we wanted students to think about how their computer is doing what it's kind of mindlessly writing code. And by covering while loops, we also got to spend time comparing for loop and while loop implementations of the same procedure. So for example, here is a function that we had them write that you might often not, that you would likely elect to write with a for loop instead of a while loop. But because we covered while loops, we could say, okay, here's how you do it with a while loop. Here's how you do it with a for loop. And we also got to break out the whiteboard, or I guess in this case, the iPad, and just walk through the execution of this function, sum first n, called on sum input. So while loops really gave us an opportunity to step outside of the step outside of the tabular manipulation is what I mean, and work on computational thinking skills. So that's what we had while loops for. We also talked quite a bit about lists. Now, the main difference between the coverage of lists in data 6 and data 8, lists are briefly talked about in data 8, is that we talked about indexing with square brackets, and that allowed us to talk about string indexing and string manipulation. And so we were able to have students work on implement a lot of functions that would take in a string and extract certain information from it, or take in a string and change some characters to uppercase or whatever. And a lot of those examples are motivated by data cleaning. And we were able to do that because we talked about string indexing and list indexing. It also allowed us to talk about the differences between lists and arrays. And this is something that comes up in Data 100, which is the course that students in the data science track will take after Data 8. So we talked about, okay, if you multiply a list by 2, what happens? If you multiply an array by 2, what happens? Okay, why are those things different? Talking about lists before talking about arrays also allowed us to break down or dissect, I guess, one of the common functions used in Data 8. So in Data 8, to create an array, rather than calling the numpy.array function, students call this function that is built into the data science package called makeArray. And so what makeArray does is you just give it a bunch of arguments, and it'll return a numpy array with those arguments. And notice here, you don't need to use square brackets at all. You just call this makeArray function. In Data 6, we didn't use makeArray. Rather, we had students use numpy arrays or np.array directly. And we were able to do this because students knew that square brackets corresponded to lists. We need square brackets because the argument that numpy array takes in is a list, and we need the parentheses as well because np.array is a function and we're calling it, right? So this syntax has proven to be tricky for students who are seeing programming for the first time, especially if time isn't dedicated to it. But because we had the time in Data 6 to talk about things like this, we were able to go slightly deeper than they go in Data 8. Okay. Another construct that we talked about in Data 6 was dictionaries, and I showed you an example in Mojify that used dictionaries. It allowed us to talk about the difference between position-based data structures like lists and key-based data structures like dictionaries. And this kind of alludes to how tables work, because you can kind of think of a table as a dictionary of a bunch of lists. We didn't explicitly say that, but we used dictionaries when we were going from lists to tables. It kind of slotted right in between. We also use dictionaries because it gave us engaging examples, and also it allowed us to talk about JSON as a file format, and compare and contrast that with CSV before moving to tables. Right, almost all of the data sets that we actually used in the class came in the CSV format, but we talked about JSON as just a thing that existed. Can be organized in a tabular fashion. And so in the same homework that we just looked at, homework 4, students had to index a JSON file that came from a Google Maps API query to extract the longitude of a business or something like that. So we had students get a taste of what non-tabular data looked like as well. And here's a screenshot from a lecture where we walked through a dictionaries example where students would take a dictionary that had area codes as keys and states as values, and sort of flip that and instead create a dictionary where states were the keys and lists of area codes were the values. Okay. So what have we talked about so far? We talked about the placement of tables, and we talked about some of the additional programming constructs that we brought into Data 6. The last big difference between Data 8 and Data 6 is visualization. So we covered things in a slightly different order. This was kind of just to experiment with how a different order might work. So in data 8, they cover scatter plots and line plots first, before covering bar plots and histograms. In data 6, we kind of wanted to try something different. So we first did bar plots and histograms before looking at scatter plots and line plots, with the reason being that bar plots and histograms kind of look at the distribution of a single variable, and scatter plots and line plots look at relationships between multiple variables. Also didn't cover histograms in as much detail. Now in data 8, histograms are a big part of what they do, and students learn frequency-based histograms where bins are not necessarily all of the same width. In data 8, they learn density-based histograms where all of the bins are not necessarily the same width. In data 6, we only looked at frequency-based histograms, and by that I mean histograms where the y-axis is count density-based, and we did that in order to, not have to cover some of the more nuanced details with histograms and thinking about proportions as areas. We also taught visualization using Plotly instead of Matplotlib. Now, we looked at an example earlier of a scatter plot that used Plotly. Most of the visualizations that students created in the class look like that, though for the majority of the semester, students didn't really need to know which visualization library we were using, because all of the visualizations are created by, .hist, or the name of their table .bar, right? That doesn't explicitly call PLT or Plotly whatever. We told students that we were using Plotly instead of Matplotlib, but that wasn't immediately obvious. The benefit, of course, of Plotly was that all of the visualizations that they created were interactive, like the one I showed you earlier. And students seem to enjoy the visualizations in Plotly. We also spent quite a bit of time in lecture talking about maps. Now, maps are covered in Data 8's textbook, and so they're kind of built into the data science library. They use a Folium backend, but they're not currently covered in any Data 8 assignments. We spent an entire lecture on creating maps, and here's an example from lecture, which shows the year in which every Walmart in California was opened. And an interesting phenomenon we discovered in lecture was that Walmart's strategy in California was to open in the inland cities first, which is why you see darker circles sort of in the interior of the state. Darker means earlier. And then over time, they sort of moved westward and opened locations in the Bay and LA. So this was the sort of differences between how visualization was covered in Data 8 and how it was covered in Data 6. But by the end of it, since the API calls that students made were the same and the content that they got was largely the same, it'll match most of what they saw, or they will see in Data 8, rather. So, like I said, the goal of Data 6, again, is not to replace Data 8, but to prepare students for it and to get students excited about taking it. Now, students who took Data 6 and take Data 8 afterwards will be familiar with most of the first module of Data 8, because the first module of Data 8 is computation, and we covered most of that, including iteration, just not some of the more inferential-based iteration examples, which is kind of like the core of the second part of Data 8. But not everything will be reviewed, right? So there will be details about histograms that students will not have seen in Data 6. There will be discussions on interpreting data from an inferential lens that we didn't really talk about in Data 6. That will all be new to students in Data 8 after taking Data 6. From the second module onwards, students will be exposed to new material, but the goal is that their programming maturity will help them focus on the deep inferential ideas, which is kind of what Data 8 is all about, without getting bogged down in the syntax, and while also feeling confident with their abilities to succeed, because they started off the course doing really well. They got the programming down. Now they can just focus on the inference. That's the goal. Any questions with the content of Data 6 before we move on to the implementation of it? I'll talk to you about some logistical details. Any questions with the content? So there's a question from Ildar in the chat. What do you think about introducing classes in object-oriented programming in data 6? Good question. That is something we discussed, but chose not to include since it was possible to achieve our course goals without doing that. And if we were going to talk about classes in OOP, it would have been towards the end of the semester. And we instead spent the end of our semester briefly talking about statistical simulations and also showing students how to build websites of their own. And I'll talk about that momentarily. Did we use pandas? Great question. No, because since we wanted to get students ready for data 8, we used the same data science library that they use in data 8. I'll check the Q&A really quick. Do students work on their passion projects at the end of the course? Somewhat. I'll show you kind of the extent to which they did that towards the end. And there's another comment. I noticed you called data frames tables. Are students confused about data frames when they work with pandas? That's more of a data 8 to data 100 question. But as Eric said, we've seen that students tend to pick it up. And from what I've seen when teaching data 100, I've been involved with that course for a while. That doesn't tend to be a huge issue for students. After a while, students kind of pick it up. You throw in social implications at the very end, sort of as an afterthought rather than integrating it. You're totally right. And one of the main things that they're working on this summer in the offering is keeping most of the technical content the same, but doing a more honest and thorough integration of implications and social sciences content into the course. We had one guest lecture towards the beginning, and we had some small discussions when talking about data sets. But yeah, you're right. There needs to be more. And there will be more this summer. Awesome. Okay. I'll keep moving for now, and we'll have time for questions towards the end. I want to talk to you about how the course was run. So first, it's important to talk about enrollment, since we really wanted to cultivate this environment of everyone is a beginner. We're all in this at the same time. We're all in this together, rather. What we did was we had enrollment by an application, and we asked students these 3 questions. Have you ever programmed before? What is your expected graduation semester, and why do you want to take this class? But really was make sure that they were new to programming. And so if students said, oh, I've tried R before in this other course, or oh, I took 60ONA, but I want to learn more, instant reject. We only took students who have never programmed before in order to make sure that the environment was one of we're all starting from ground zero. Enrollment was also capped to 30 students, right? Differences between data 6 and data 8 is that data 6 is small, right? There might be demand for this course to be 400 students in the future, but that would kind of go against the whole purpose of creating this course, which is that it's not an ultra large course. So that, and also because it was sort of a pilot offering, we wanted to cap enrollment to 30 students. Now, we started marketing the course relatively late into the enrollment cycle for various reasons. We kind of started, I believe, in December, early December, and students start enrolling late October. So we had 62 students apply. 45 were given seats, and of those students, 25 started the class. Various students dropped or said, I'm going to take data 8 or whatever, and 21 were in it by the end of the second week after figuring out, they're not interested in this, or they have a scheduling conflict, so on and so forth. And 18 students ended up finishing the class. So you'll see a lot of numbers that are out of 18 moving forward. Okay, so how did this course actually work? So campus has a rule saying that if a course is offered for N units, students should not work more than 3 N hours. Now, unfortunately, a lot of courses, especially in computer science here, don't violate this principle, and students spend way more time. But we really wanted to make sure students only spend 9 hours a week on this course on average, because it was a 3-unit course. And so here's how we kind of allocated our time. We started with 3 hours of lecture per week, Monday, Wednesday, Friday, 50 minutes, held on Zoom. Everything was done synchronously. We also had 1 hour of lab per week immediately following lectures on Friday, also done on Zoom. Now, instead of having a lab assignment, we instead spent the first 20 minutes or so of lab reviewing the concepts that were relevant to that week's homework, and the latter half of lab working on that week's homework. And I'll talk about homeworks momentarily. We would then estimate students would spend the remaining 5 hours of their week on homework. So 3 plus 1 plus 5 is 9. And it turns out from our weekly surveys, we generally hit this target. And I'll talk about weekly surveys momentarily as well. Like other data science courses, I'm not really going to talk too much about infrastructure, but everything was linked on the course website, so you can see all of that there. There's also a link to a GitHub repo at the top of the website where you can go and look at all of our lectures and assignments without having to log into the Berkeley Data Hub. But yeah, students did indeed spend on average 5 hours per week on homework. We also had 4 hours of course, optional. The instructors held 2 of them, and our course staff each held 1. So students had plenty of help, especially because, remember, we finished the course with around 18 students. That was kind of our steady state. So students had plenty of help. I want to talk about a quick check. So this has done commonly. This has been done commonly recently. But to facilitate active learning, what we did was during lecture, we would stop several times and give students a question to answer. We called them quick checks, but they're just short questions that were either multiple choice or short answer that we didn't grade on correctness. Rather, students just had to do them, and they were worth a small part of their grade. And what students would do is they would stop, go over to this platform called Ed, answer the question that was on screen, and then we would take up the solution to this question together. Now, these quick checks were hosted on the platform Ed, which we used both for quick checks, so questions each lecture, but also for discussion in lieu of Piazza or CampusWire. Here's an example question on Ed. So students are shown the question. It's both in the lecture slides and on Ed, and they just type in the answer and hit submit. We thought this was pretty helpful. Now, we'll talk about homeworks. Homeworks were a big part of the course because that's where students spent the majority of their time. We had 9 homeworks throughout the week. Throughout the semester. They were assigned roughly weekly, but in weeks where there were quizzes, students were given 2 weeks, and there's also spring break and whatnot. So it was roughly weekly. And here you can see the topics for each homework and the data sets used in each. The first 4 homeworks didn't involve tabular manipulation at all. The next 4, 5 through 8, were sort of the core of tabular manipulation and visualization. And this 9th homework was where students got to create a GitHub Pages website using a data set that they chose. The homeworks before that were just standard Jupyter notebook assignments, similar to those in Data 8, where there's a mix of programming questions and interpretation questions. We used the AutoGrader stack that Eric and Chris Piles talked about in a session yesterday. And homework 9, like I said, is open-ended. All students had to do was find a data set of their own. It had to fit certain criteria, and make a visualization of their own, which also had to fit certain criteria, and put that on a GitHub Pages website. And since we have time, I can show you an example of the kind of things that students created. I'll open this up here. This is the example we created in lecture, but students created this kind of thing. So this one's the average temperature in Chicago and San Diego. We showed them how to embed things like tweets or Instagram posts or whatever else they wanted to put in their website, and they would embed this interactive plotly graph into their website. So it kind of looks production quality, and students got to pick whatever they wanted, and they really had fun with this. And they also had to add a couple paragraphs and whatnot. So a comment from Eric. So the project was also familiarity with GitHub. To an extent, we didn't have students do anything locally. We kind of just treated GitHub as this place where, you make an account, a commit is like saving your work. That's not entirely accurate, but we use GitHub to create this website. And yeah, they had to make GitHub accounts and make a repo and whatnot, though I wouldn't say we taught them GitHub. But yeah, students really had fun with this homework. And in the comments, in our end of semester survey, students were kind of split between this homework and homework 4, the one with emojis and the image filter, being their favorite homework in the course. Okay, we'll switch back to the other tab. Okay, so that was the open-ended component. largely everything else, they were kind of just working on the same assignment as everyone else. At some points, they were able to put their own flavor into it, like pick their own emoji or whatever, but largely they were kind of doing the same thing as everyone else. Cool. I'll talk briefly about how we examined students in the course. So instead of having one large or two larger midterms, we instead had 3 quizzes. So if you remember, when we first showed you the content in Data 6, it was kind of broken up into 4 modules. There was 1 quiz at the end of each of the first 3 modules, worth 5% of their grade. And in terms of how the quizzes were administered, we did the first quiz in the form of a Jupyter notebook with inline auto-graded tests. In that case, we had both hidden and public tests so that they couldn't reverse engineer their way to a perfect score. But what I realized was, since this was their very first programming assessment ever, their code had a ton of syntax errors, and most of the time the auto-grader wouldn't run at all. So we had to manually grade things. And so we said, instead, moving forward for quizzes 2 and 3, we would do things with a Gradescope online assessment where we could easily give partial credit to coding problems, but also ask multiple choice and short answer questions. So we asked like conceptual questions involving, what happens if you join these 2 tables, or what happens if you pivot these 2 tables, where students had to type in a number or give an explanation. We used Gradescope online assessments for that. The final exam was in the same format as quiz 2 and 3, Gradescope online assessments, and we had a clobber policy, which is where, if a student does better on the quiz 2 portion of the final exam than they did on quiz 2 originally, their quiz 2 portion of the final exam would replace their original quiz 2 score. And here's a screenshot from quiz 2 of what a Gradescope online assessment looks like. There's a question in the chat, what is ED? If you go to edstem.org, you'll see the website, but it's like a replacement for Piazza or any other discussion forum you might have used. Good question. Okay, so we talked about the content in the course, the goals of the course, why we did what we did. We talked about how the course was run. We'll spend talking about how students did and how students received the course with the remaining time that we have. So here we have the reported understanding, self-reported level of understanding, rather, for each main topic in the course. And so while we had weekly surveys that accompanied each homework assignment to get students' level of understanding on the content they just saw in class, this was more of a reflection at the end of the semester, how well do you get everything? And so it's pretty clear that for loops and while loops are an outlier, in that students didn't feel as comfortable with for loops and while loops as they did with the content towards the end. They felt quite confident with tables and visualization, and even they were pretty confident with writing functions and control flow, but loops were kind of iffy. And we also knew this, like this was not a surprise to us at the end of the semester. We knew this because, like I said, we had these weekly surveys where we would poll students, okay, how much did you understand of the most recent lecture? How tough was this most recent homework? And so what would we do in the future? One, we'd probably cover for loops first because students, both in the survey and anecdotally from talking to them, struggled more with while loops than they did with for loops, and we might dedicate more time to them. We initially planned on covering while loops in one day, then lists the next day, then for loops the next day, and moving on. But that wasn't really calibrated to where the class was comfortable with. And so on the fly, we had to dedicate a little more time to loops and move some things around. It also helped that in the lecture leading up to each quiz, the 2 lectures leading up to each quiz, rather, we spent time reviewing the relevant concepts and also working through 2 and 3. The review was in the form of a case study, looking at involving everything that we just did. For quiz 1, it was more just, okay, we got to drill through some for loops and while loops. Okay, so we said that the point of the course was to prepare students for Data 8. It's worthwhile seeing how many of them actually plan on taking Data 8 afterwards. As you can see, the answer is not that many, right? Only 50% of the course will probably or definitely take Data 8, at least based off what they said in our end of semester survey. Even fewer said that they would major or minor in data science, right? Many students said they're not happy, like it's not happening, or they're graduating, or they're probably not going to change their minor. But most are interested in pursuing data science further. And so, I mean, there are a variety of factors that lead into their answers here, but most of the students in our course were juniors or seniors as a result of how we marketed the course. And here you can see a distribution of the years that students were in. How we marketed the course was by reaching out to the major advisors of non-STEM majors across campus and saying, hey, can you tell your students about this new course that we're offering? And when they did that, they would send it to their majors. But in order to be a declared major, you're likely already a sophomore, or junior, or senior, right? Most freshmen are not declared in any major. So we got older students through that process, which is fine. We still encourage Data 8, and more broadly, we encourage most students to care about data science and want to pursue data science further, even if they're not all taking Data 8 afterwards. But in the future, we might be a little more targeted with how we advertise the course. We can also talk about how satisfied the course. I mean, based off of the numbers, they seem to be quite happy. How much do you feel like you learned in the course, and how happy are you, with your decision to take the course? Most students answered 4 or 5 to that question. It's fine, and students can be happy with the course, but we can't yet conclude if we prepared them for Data 8 because they haven't taken Data 8 yet, right? And we also can't comment if their positive reception, to the class was because of the content decisions that we made, or if it's because the course was small and they were able to get a lot of attention. Like, would they have been just as happy with this course if it was Data 8 with 20 people? Who knows? Maybe, maybe not. And we can look at student testimonies if you want, but students were happy with the course. But again, we have to take that with a grain of salt. Okay. So what's next? Well, at Berkeley, this course is going to be offered again this summer. It's going to be taught by Ian Castro, who taught, and Isaac Merritt, who was the TA for the offering this spring. And it's going to be largely the same course as the Spring 21 offering, with more social sciences content embedded, maybe some content removed, just because in the summer it's being offered in the 6-week summer session. It would be kind of hard to do all of this that we took 15 weeks to do in 6 weeks. It'll be taught to students who are in the SEED program. I believe SEED stands for Exceptional Scholars, Supporting Excellent Scholars Through Equity and Diversity, I believe is what SEED stands for. So it's going to be taught to students in that program. The future of the course after that is currently unknown, but I've been told the goal is to make sure that it's regularly offered, because these students did have a positive experience with it. But the other question is, okay, what might happen to this course after Berkeley, or outside of Berkeley, rather? So who should consider building or taking some of these materials into their program? Well, if you have a Data 8-like course that a subset of your students struggle with, maybe a course like this could work. Maybe if you have or don't have a Data 8 course, but you want to teach an introductory programming course with a data focus, maybe a course like this would work too. Though, because it's kind of brand new, it remains to be seen if this will actually be effective in the long run. Who knows? We'll find out. That's all I had prepared. So we can spend the remaining answering any questions, though I have a link here with the slides, and also this presentation was based off of the work I did in my master's report in my 5th year's master's here at Berkeley. So if you want to read a little more of what we did, there's a little more detail there, so you can take a look at that if you're interested. But yeah, we have about 8 or so minutes for questions. I'll stick around if anyone has any.
Nice job, Suraj. You're just a great presenter.
If
you click over to the Q&A tab, there's a few questions lined up in the Q&A tab.
Got it. So we'll start at the top. How does that attrition rate for the course compare to Data 8? Do you have high dropout rates in Data 8? Good question. I don't have the answer to that. I don't know. I got questions, or sorry, the data I got for data 8 was specifically to put in like my master's report, and that's where the data in this presentation came from. But that is not something I looked at, unfortunately. Good question, though. Did they provide any feedback on why they dropped the course? Yeah. So going from the 21 to the 18, we still, a lot of students were impacted by the pandemic. And so 2 of the students who dropped from the 21 just had external factors, rendering them unable to keep up with the course. And 1 student, in fact, no, that was the case for all 3 students. They had external factors and they just weren't able to keep up with the course. So that's why we went from 21 to 18. Going from 25 to 21, some of it was scheduling constraints because we required attendance in the course and attendance was a part of their grades. But a couple students left because we were moving a little too quickly at the beginning. And that's what they told me in emails afterwards. So, and we kind of knew that. And after the 3rd week of the course, we kind of slowed the pace down a little bit. But yeah. The question, is there a lecture on debugging code? Unfortunately, no, though that is something I originally wanted to do, but it didn't make it in. We did talk about, debugging, and since we had a relatively small course and we had quite a bit of staff support, students did have a lot of interaction with us, and in those interactions, they hopefully picked up some debugging skills, but no, there wasn't a dedicated lecture for that. There probably should have been. Let's see, what else did I answer? That. Okay. What math topics did you cover? Good question. None really. Some of the function examples that they worked on involved some, mathematical formulas. So, they were exposed to some math there. When talking about histograms, there was some math there in terms of calculating what fraction of observations were in a certain range. But other than that, no, we did not. This was not, meant to replace data 8. They'll get their treatment of inference in data 8. We were trying to do something, tangential, but not the same in this course. So we didn't really have much math here. What makes data 6 different than a CS for all CS0 course? Good question. And like I said, I don't think this replaces. It doesn't replace anything. It's just something that we didn't already have, this kind of thing at Berkeley. I think it's an alternative CS0 for people who are interested, who somehow know that they're interested in data science more than anything else. How we originally thought of this was as a CS0 or like a DS0 for data 8, if you think of that as a DS1. It's different because the flavor is different. We do talk quite a bit about tabular manipulation, and they serve kind of similar goals, but they differ in their approach, I guess. Cool. Any other questions?
From Carlos. Not necessarily a question, but a comment maybe. You want to talk a little about that? He says, I would assume Berkeley students are on average stronger than students at smaller colleges. This is
sorry, yeah, I did do that, yeah. I mean, okay, sorry about that. Yeah, so to Carlos's comment, yeah, I mean, I think regardless of the institution that you're at, whether you're in high school or at a smaller college or at Berkeley, learning programming for the first time is challenging, right? It's kind of different than anything else you've ever done. So yeah, I mean, would some students have been able to keep up with the faster pace? Definitely. I mean, students go into data 8 without prior experience and they succeed. Students go into CS61A, which is our CS1 for CS majors, and they succeed. So, it's not that everyone necessarily needed to go at this pace, but we designed this course to go at this pace. And that's kind of who we attracted and who we were trying to serve here. And Brian Harvey has a great point about CS10 is taught in a block-based language, so you don't lose students at the beginning from struggling with syntax. You can focus more on higher level ideas like abstraction, which is huge in CS10. To those leaving, thank you for coming out. I appreciate it. A couple more questions in the Q&A. Did you like Ed more than Piazza? Great question. So it's kind of hard to answer that because the course was so small that we didn't deal with some of the issues that we have in other courses on Piazza. And what I mean by that is when teaching data 8 or data 100, oftentimes Piazza will get really buggy just because, there are so many comments on a thread because, people are stuck on one question in a homework and it gets really buggy and the search gets pretty bad. We didn't deal with any of those issues because we only had 18 students, so it's hard to compare them directly. I did enjoy using Ed, and I think moving forward, I would definitely consider using it again. Though for our use cases, it was kind of just a different UI, a more modern UI. It felt like newer, but I don't think there was a huge difference over Piazza for our use case. For the quick checks, we used Ed's lessons feature, and that I thought was really nice. The alternative would have been putting all of the quick checks on Gradescope, but we already have Gradescope for uploading assignments and exams, and if we had one assignment for every lecture's quick check, Gradescope will get pretty crowded pretty quickly. So that's why we wanted to put it on something else. From Matthew, can you say a little bit about what students were finding difficult about while loops? If you were teaching them again, what would you do differently? Great question. I think a lot of these struggles would have been alleviated if we just knew that we would have to dedicate more time to it at the beginning. We kind of, in one lecture, earlier that week, we said, okay, here's how if statements work. You have an if, and then something's indented, and the indented code runs. And we kind of approach while loops as being an extension of that, where like, okay, if this condition is true, you run the indented code, and then you just repeat that process over and over again. And the examples that we looked at in that lecture weren't too crazy, but I think we just assumed that it would follow naturally from if statements when in reality they don't. So I think we would have dedicated more time to while loops. And my hunch is that students are more comfortable with for loops. Now that could be because we spent more time on for loops throughout the rest of the semester in dictionary examples, and there were some table examples. So I would consider putting for loops first, maybe while loops later, though not entirely sure if that would make a huge difference, but probably what I would try. Cool. I think we're out of time, but thank you all for coming out. I appreciate it, and I appreciate the comments.
Much. Thank you all for coming in. And if you have some more time, we actually got one more comment.
Sure.
Actually, you just explained the for loops anyway.
Okay, awesome.
Yeah.
To Brian's comment, yeah, I agree. That like I didn't have the words to say it like that, but yeah, that's kind of what I was getting at. So thank you for that.
Thank you so much all for coming in, and thank you, Suraj, for presenting. What an amazing class. And the videos are available on YouTube. I just posted the link, and the slides are available as well. We'll send out the slides most likely after the workshop is over.
Yeah, the one thing I'll say about the videos is that we didn't tell, like, you can use them as a reference, but they shouldn't be posted anywhere because students didn't know about that. So they're not public in that sense, I should say.